This
completed
conference
his
will now be
master's
recorded.
in 2010 in Power and Energy Systems. Recently, in 2018, he has achieved his doctorate on optimum sizing of SPV powered irrigation system based on field condition, a case study of reverbed pump sets at Jain University, Bangalore. He is currently working as a professor in Basaveshwar Engineering College, Bagalkot. Sir has published many technical papers at international journals and international conferences, and even Sir had published a book on chapter Optimum Sizing of SPV Irrigation Systems based on field conditions in August 2018. As in earlier days, he had conducted seminars and workshops, events successfully. It's an honor for us to have such a personality with us today, who will share his knowledge on energy conservation in irrigation system. With this, I request Sir to take a lead and continue the session further. Thank you.
Ronad sir?
Yes, sir. Am I audible?
Presentation.
Thank you, sir. Thank you very much. Hope I'm audible. Yeah, Alok, am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Okay, thanks for the confirmation. Good morning, all. I'll be sharing my screen. Then I will go ahead with the presentation. Okay. So today I will be discussing energy conservation in irrigation systems. The moment the word irrigation comes in picture, like everybody will be interested in this, like what might be the topic of the presentation, or even the contents also. Now what I'll be presenting is the irrigation systems, the existing scenario, energy conservation opportunities in irrigation systems, the methodology for energy conservation in irrigation systems. I'll be presenting some case studies. Then I will be demonstrating the methodology that is already employed for the achievement of energy conservation. Okay. So this slide gives some important information, interesting information actually, like why the energy needs to be conserved. And that too when we are speaking about irrigation, which is the very important aspect as far as the Indian economy is concerned. The consumption of fossil fuels, you can just quickly observe this in the present time where all our generation is taking part. So we have consumed most of the fossil fuels. So maybe in and around 2000, most of the fossil fuels have been consumed, and maybe very soon they will be coming to an end. So it is quite obvious that we have to take care about these things. Then this one picture indicates there is some significant need for conservation of the energy. Then there are many works and approaches which are already been taking place. And look at this. So whenever we speak of energy conservation, I have shown an example with reference to electric vehicles. When we are speaking about energy conservation or sustainability with reference to this electric vehicles, well, this is the expectation that electric vehicle will be green and it will be sustainable and it will not be giving out any emissions. But in practice, if you are going with this coal-fired power stations, well, only the color of the car will be green. Rest everything remains as it is. So looking into this, this is one of the important aspect where these two images very clearly indicate the amount of energy and electricity that is being consumed or taken by agriculture, and in fact some part of that will be irrigation. So in the first figure, it indicates this is about consumption of the energy and this is about electricity, sector wise energy and electricity consumption. Now when we look into this, so you can look at this, agriculture is taking 7% of the entire energy part. And when it comes to the electricity, look at this, agriculture alone is accounting for 29%. Now this that I have taken from Terry, the Energy and Resource Institute details. And only this slide indicates that, well, agriculture is contributing to a major part of the energy consumption. So of course, this is one of the main component for our GDP also. It means we have to give sufficient opportunity for the consumption here. We have to promote this, but also wherever there is provision, we should always be able to conserve that much amount of energy. Now comes the question, what are the challenges? Now, regularly, whenever we speak of conservation, well, we keep hearing these words. Nowadays, even all the ESCOMs, ESCOM, BESCOM, and all these ESCOMs are promoting this, how exactly we can save electricity and why exactly we have to conserve electricity. And when it comes to irrigation, these are the challenges now. Now, whenever I speak of agriculture, irrigation is not only the component where electricity is being consumed. So irrigation is one major component. Other applications are there, farm activities and harvesting, post harvesting, and all many activities are there in the agriculture which consume electricity. Out of that, one major component is the irrigation. If you ask what is the T&D losses in Karnataka, so maybe even for India also, for electrical engineers, so if I ask what is the transmission and distribution losses in system, the obviously answer I will be hearing from your side will be maybe 25%, 30%, 35%, and some extent up to 40%, something like this. But for Karnataka, if you ask the officials, it will be quite lesser than that. They will never tell it is 30%. The reason for this is major component of the grid, that is the load, is agriculture. So at least around 20% of the load will be agriculture irrigation load, and all these irrigation loads don't have any metering infrastructure. Metering infrastructure is not there. It means all the management gurus keep suggesting, if you want to improve something, if you want to modify something, or if you want to improvise some methodology or the system, always it should be measured first. So when there are no metering facility at the irrigation pumps, well, it is very difficult to monitor this, very difficult to improvise that. So whatever the energy that is being consumed by farmers, so all that is accounted as, all the losses are accounted as part of the energy that is consumed by farmers. So obviously, even the government officials will also have this difficulty to monitor or measure how much amount of energy is being consumed by farmers, because irrigation pumps don't have metering facility. Now there are good amount of schemes are available for the farmers, like anyhow, for farmers, water is available at the free of cost. Electricity is also available free in Karnataka state government. In some cases, even the irrigation pumps are also provided in free of cost. So after all this, we keep listening so many issues with reference to farmers. But this has become a business also, because electricity is freely available, water is available in the rivers. Whenever it is available, then pumps are available for the farmers. Then some of them will use this as a business also. Like they will not be bothering about how much amount of energy is to be consumed, or there is no option, or there is no thinking option for farmers for the conservation. So what happens in this scenario is, since the water, electricity, and the pumps are available for the farmers, which are with no cost, there is no limit for conservation or consumption of the electricity. So what engineers can do here is, we can make some methodology such that the irrigation pumps, whatever the energy that what they are consuming, that can be conserved. So that can be limited without affecting the farmer's requirement. So just to achieve some energy conservation, we should not affect the farmer's requirements. So whatever the water requirement that the farmers are having, that has to be fulfilled. If once it is fulfilled, then if you are consuming or if you are conserving or saving some electricity, that is the biggest achievement. And how it is done, that is what the topic of my presentation. So overall, what I will be discussing is the energy conservation in irrigation systems. So for electrical engineers, this water flowing in the pipe is quite very much similar. One-to-one analogy can be employed. So this slide indicates quite interesting information for electrical engineers. Of course, if many mechanical students are there in the as a participant, they will be having some glimpse about these things. Now, electricity in a wire is very much similar to water that is flowing in the pipe. The amperes, which we call flow of electron, is nothing but the flow rate of the water in the pipe. Voltage means it is the pressure available in the water which is flowing in the pipe. The watts power, it is for us, it is amperes, product of volts and amperes. For water which is flowing in the pipe, it is product of flow rate and the pressure. Resistance is the flow opposition offered for the flow of current, whereas here we will be using friction word and the losses in the pipe. So similarly, we have similar components, high voltage, high pressure in this side. Small wire is there, small pipe. It means whenever high voltage is employed for small wires, we know that it will get burnout. Same thing happen for this water pipe also. If the high pressure is there and very small pipe, obviously pipe will also get blown out. So this is what the meaning is. Now we'll quickly see how exactly the centrifugal pump operates. All the irrigation pumps which are presently in use, which are connected to grid connected, will be using these centrifugal pumps. So this is the typical centrifugal pump, where one side is the suction side, another side is the discharge side, where water will enter into this, and in this impeller water gets rotated and it will discharge to this, and through this pipe network will be connected at this discharge point, and water will reach to the destination where exactly irrigation is to be done. And this is the shaft where we can couple this to a motor. Motor may be a DC motor or a AC motor, a source may be anything. Ultimately this shaft is to be rotated. Even this can be, if it is not a centrifugal, this can be operated by hand or bicycle, or any option can be coupled. Ultimately this is the scenario I will be making use of in this entire presentation, centrifugal pump. And this is another view of centrifugal pump, which is DC water pump, usually used for SPV coupled operation. So this is the footwall, we usually call as footwall in our regular use. So it is at the starting point of the suction pipe. Water is taken to this point by virtue of the centrifugal action. Then water is rotated in this impeller, then it is discharged. So this is called as discharge head. So this is called as suction side head. The word head, whatever the indication is there, all the time it is the power requirement for the irrigation pump. Now this is about quick information about the irrigation. So we all know the irrigation is and agriculture is one of the important aspects as far as Indian economy is concerned. India is country of more than 6 lakh villages, and more than 70% population is involved in agriculture and allied businesses. So there is an estimated 21 million irrigation pumps, out of which 12 million are in electricity. So some of them in Punjab and Haryana, they'll be using some diesel pumps also. So electricity consumption by irrigation pump sets alone accounts between around 20% of India's total electricity consumption. Of course, which has become a burden on the grid. Of course, we cannot call it as a burden because irrigation is and agriculture is important aspect. But when other options are available, this can be eliminated. In that angle, well, it is a burden when other options are available. Farmers install excessive pump capacities and multiple pumps. So this happens because the irrigation pumps don't have any metering facilities. Farmers in Karnataka at least don't pay the electricity bill for whatever they consume, and this will lead for what is called as cascading of the excessive pump sets. So if the electricity is available over 6 hours, then rather than using only single pump set, farmers can use 2 pump sets and they can pump sufficient amount of water. This is what the farmers think. We cannot call it as a mistake because provision is available from the farmers end. But as engineer, what we have to do is we should not avoid farmers using the electricity, but what we have to do is we have to optimize use of the electricity without affecting their requirement. Now this issue can be resolved by identifying the excessive installations and resizing them optimally. I'll be using this word optimally and optimization, which indicates the exact suiting of the exact requirements of the farmers. The optimized irrigation load will reduce the burden on the grid, as well as it will also help us to achieve the energy conservation. The alternative option, that is a sustainable option, is SPV powered irrigation pumps. Well, if all the irrigation pumps are coupled to SPV solar PV system, well, you can imagine 20% of the load is disconnected from the grid. It means huge amount of carbon emissions will be eliminated from the system, or they will not be eliminated to atmosphere. But the question is how to move from conventional grid connected irrigation pumps to SPV powered irrigation pumps. In the present scenario, if we ask any of the farmers to directly shift from the existing pump to SPV powered pumps, it is very difficult. Because farmers, whatever the pumps that they are installed right now, are quite of good higher size. For the same size, if you want to suggest them SPV pumps and corresponding SPV panels, cost of that system will be very high. For that, even if you want to go for SPV system, then also the pump size should be reduced. The word reducing may not be suitable. The pump size should be optimized to their actual requirements. Now the question is how to find out the actual requirement. Now this is the typical block diagram of the irrigation pumps. So energy is required, either it may be solar or it may be grid connected electricity. There will be a motor and a pump. Motor is a device which converts electricity into mechanical energy, and pump is a device which converts mechanical energy into hydraulic energy. So in the market, we will get the assembly of motor and pump together. So that is what we call it as water pump. That's all. It is a combination of motor and pump assembled together. So water source will be there. It may be bore well, or it may be open well, river bed. It may be anything. It can be pumped and can be stored to a storage tank, or it can be directly supplied to the crops. Now the question comes energy conservation and how it can be achieved in irrigation. The definition of energy conservation, hope all of the students might have already aware about this. When I use this word energy conservation, it is not just saving of the electricity. Energy conservation, the definition of energy conservation states that saving of electricity without affecting the comfort zone. Suppose if you want conserve electricity in your homes, it means it is not that all the lights to be switched off, all the fans to be switched off, and all the loads to be switched off. It is we have to switch off all the loads without affecting our comfort zone. Our regular activity should be continued. Wherever excess consumption is there, that has to be identified, then it has to be addressed or it has to be eliminated. And for homes and our domestic loads, our institution campuses, we can readily define how to save the electricity. If I ask any of the faculty member, if I ask any of the student, they will give list of the options how electricity can be conserved in campuses or homes. but how it is consumed, how electricity is conserved in irrigation. This top point itself is very important. Now for farmers, the comfort zone is water requirement. For a room where we are sitting, if you want to save electricity, comfort zone is sufficient amount of lighting. The incandescent bulbs can be replaced by CFLs while electricity is conserved. But for farmers, their comfort zone is their water requirement and their reliability. Now, without affecting their water requirement, we have to conserve the electricity. Now the question comes, how to know the water requirement? Now this is where the point begins, how to conserve the electricity in the irrigation systems. The design of irrigation schemes for energy conservation. It has some following number of steps. First, we should know what is the water requirement of the crops. Either we have to ask the farmer what is your actual water requirement for your agriculture land, then we have to suggest him irrigation pump size so that energy can be conserved. For that, we have to manually calculate water requirement, otherwise we have to employ some methodologies. Then types of the irrigation, there are different types of irrigation systems are there: surface irrigation, sprinkler irrigation, drip irrigation. So when you want to improvise the system, obviously we have to use this new methodologies also. Irrigation patterns, how exactly water is to be fulfilled. So study of pipe networks. The pipe networks are to be optimally suggested and optimally used. We should know what is the geographic condition of the agriculture land, how much far it is located from the riverbed or maybe from the borewell. Water has to travel for a kilometer means, then we have to design the pipe networks also very optimally. If you use a very small pipe or a large pipe, large diameter pipe, and if you are using some uneven irrigation pump, heavy amount of electricity will be consumed. There are basically three main steps. First step is the crop water requirement calculation. Second one is hydraulic head calculation, that is pressure requirement calculation in the irrigation system. Third one is pump calculation, what is the rating of the pump. Now this diagram very clearly explains the methodology that needs to be employed for energy conservation. There are three colors used in this diagram. The green colored part is the agriculture part. The red colored part is the opposition offered for the flow of water in the pipe. Third one is calculation of HP rating of the motor. So ultimately what we are doing in this process is we are looking into the farmer's requirement and resizing his actual requirement for the irrigation pumps. Then when we optimally suggest him irrigation pumps, obviously energy conservation will be achieved. Now for that, we have to observe the type of the soil he is having in this particular land, temperature and rainfall and sunlight in his agriculture land, crops, what he is growing, method of cultivation. Looking into all these climatic factors and the type of the crops that the farmer is growing in his agriculture land, we have to calculate the water requirement. Then on the other hand, the heads of the pressure losses are to be calculated. Frictional head, it means when the water is flowing in the pipe network or maybe PVC pipe, it will face some amount of friction. By virtue of that, some amount of energy will be lost. Due to velocity, there will be some pressure. If they are using some bands, if you are using some 45 degrees bands or 90 degrees bands, while water is flowing, some amount of energy will be lost due to friction. Same thing happens when there is a change in the area of the pipe. Again, the major thing is static head. These are called as dynamic heads, which are happening due to flow of the water in the pipe. On the other hand, static head means this is the energy lost due to the static head. Maybe there is some amount of height up to that water is to be lifted. There is some amount of height from which the water is to be pumped. That is, there are two parts. One is suction side head, another one is the discharge side head. If the open well is having 10 meters depth, it means 10 meter depth is the static head at the suction side. If the 10 meter height is there in the discharge side, water is to be pumped for 10 meters, then that is called as discharge side static head, and the total head will be algebraic summation of these static head, that is suction and discharges. Using all these possible combinations, we have to calculate total head offered. Then this is the exact head that is available in the agriculture land. This is the exact water requirement in the irrigation system. Based on these two components, we have to design or recalculate the HP rating of the pump. Now there are different schemes available or the systems available. Most of us, including me and whatever that our generation is there, most of us are from farmer background family. Either us or maybe our parents, or at least our grandparents will be farmers. So most of us are well aware about this. This is called as surface irrigation, first one. The second one is sprinkler, and the third one is drip irrigation system. So what exactly happens in all the three, every one of us are well aware. Now what happens is, when we want to conserve energy, then we should make use of the best technique which will help us to conserve the energy. So in the first case, a sufficient amount of water will be given to the agriculture land. But what happens is, there will be some losses. So you might have experienced there will be some cracks in the agriculture land. So water will be supplied to those cracks. So sufficient amount of water will be lost in that. That amount of loss is called as percolation losses. So this may not be supplying crop water requirement. That will be supplying to the earth. That's all. That will not be supplying directly to the crops. If you are using drip irrigation, well, the water will be directly supplied to the crops. Of course, water will be conserved. Then along with that, electricity will also be conserved, because we'll be requiring a smaller amount of irrigation pump capacities. So we have to employ these methodologies also if you want to save electricity. The same thing in our homes. If whatever the load system is there, if you want to conserve electricity with the existing scheme, it is difficult. So we have to replace all the loads, incandescent bulbs by CFLs. We have to remove old motors and employ new energy efficient motors. All these things has to be done for homes or domestic loads, or it may be anything. Same thing should be employed for irrigation system also. These has to be improvised. Then comes the first step, crop water assessment. We have to actually calculate water requirement of the crops. Now there are many methods available. This is one method which I am explaining. Concept of evaporation and transpiration. Together it is called as evapotranspiration. In your earlier studies, maybe in botany, you might have heard these words, evaporation and transpiration. Together it is evapotranspiration. The water that is given out to the atmosphere is claimed as the evapotranspiration. So it is called as ET crop. It means the reference crop evapotranspiration. There are some crop factors. So these crop factors will be deciding the crop water requirement. I will directly show some of the crop water requirements. So these are the different climatic data which are required to calculate crop water requirements. Now if you ask the farmers what is the water requirement for the different crops, well, they will always suggest some water, but they will not be able to suggest water in terms of the liters. So if you ask farmers to tell water requirement in terms of liters, then it is little difficult for them. They are not used to that system, but that is required for us for designing the irrigation pump calculations. So for calculations, we have to make use of the best method which will give the accurate water requirement. So there are different methods, Hargreaves method, Turk method, Thornweight. There are different methods where this horticulture and agriculture researchers will be aware of these things. And these are the climatic data requirements corresponding to each method. Which method we have to select? That depends on the climatic data availability. If you have a weather station in your agriculture land and in that particular location, well, whatever the data available with you, based on that you can select the method. Ultimately, we have to calculate the crop water requirement of that particular agriculture land. Once the crop water is available or the ET crop is available, so look at this. This is indicating the crop water for different crops. So I have listed some of the crops which you will be quite usually familiar with: sugarcane, cotton, sorghum, tomato, onion, sunflower, groundnut. So, and also I have listed the crop water requirement per day for hectare. So this is in terms of liters per hectare per day. This indicates sugarcane needs 71,300 liters per hectare per day is the meaning. It means, so this is the exact crop water requirement of a sugarcane crop if it is grown in a 1 hectare. Then what you have to do is you have to design the irrigation pump only for this 71,000 liters per day. So if you look into actual installation of the farmers, obviously it will be quite larger than this. So why it is so? There are a number of reasons why farmers installed higher irrigation pump capacity. There are many issues, like they may not get electricity every day, water may not be available all the time, so they will go for some higher irrigation pump capacities. They will supply the water as and when it is made available to them. So but for as engineers, for us, this is the information we have to make use for designing the irrigation pumps. Now this is about the crop water assessment. For different crops we are available with the water requirement. Now second part is hydraulic head assessment. That is it is very much similar to a resistance assessment. If you want to design a wiring system, then we'll be calculating resistance in different parts of the network, parallel and series combinations as electrical engineers. It is very much similar to that. There is a pipe network, PVC pipe network in the agriculture land. It will have typical network, so it cannot be a straight line pipe network. So it will have some good number of bends, it will have some different diameters, all those combinations will be there. According to the actual structure of the PVC pipe network, we have to design the irrigation scheme. For that we have to calculate the energy that is going to require or the loss in the system. So hydraulic head offered to the pump, it will have different combinations. In the earlier slide I mentioned there are two main types. One is static head, another one is the dynamic head. Static head is the static height, all the time it is available on the irrigation system. Either it is suction side or the discharge side. Usually in our homes we will have suction side very less, discharge side will be maybe 2 floors or 3 floors. That is the discharge side height for our water pumps which you use in our homes. Whereas in the irrigation system, suction side will be a river bed, maybe 20 or 30 feet green colored pipe will be there. So that is suction side pipe. Whereas discharge side, water might be pumped to a sufficient larger distance. Maybe sometimes it will travel up to 1 kilometers also in the river bed systems. So these two are the static head, suction and discharge. And there are different types of losses are there, as which are called as dynamic losses, which are due to the flow of the water in the pipe. This slide indicates different losses which are going to take place in the pipe network. Head loss due to friction and the corresponding equations also I have presented. Head loss due to expansion, contraction, head loss due to bends which are used in the pipe network. Head loss due to walls also I have mentioned, because there are different types of the walls used. T structures are used in the pipe network. All the information can be employed and head loss calculations can be calculated. Now assessment of flow rate and the pipe diameter. So typically total water required per day has to be supplied within the span of electricity supply hours. Now for Karnataka, we know that farmers will be made available with 6 hours of quality power. Sometimes in summer seasons it will be reduced to 3 hours or Many options will be there according to power availability. But in general, for Karnataka, it is freely supplied, but it is supplied for 6 hours. So based on that, in a given day, if 1 lakh liters is to be supplied for a given agriculture land, it means 1 lakh liters are to be supplied in a span of 6 hours. That is liters per hour. That is the calculation we have to employ in our design. Suppose if 3 hours is the supply hours, then obviously we have to recalculate the supply flow rate of the water. Now you may get a question like, sir, like supply electricity supply hours, sometimes it will be 3 hours, sometimes it will be 6 hours, sometimes abundant amount of power will be there, sometimes 9 hours will also be supplied. What is the methodology? We cannot keep calculating, we cannot keep replacing the irrigation pumps oftenly, but in general we have to use some optimal amount of electricity supply hours for calculation. Again, for a given farmer, a farmer will be using growing the different crops. Sometimes he'll be using sugarcane, groundnuts, maize, or different crops he'll be using in his crops, in his agriculture land. For which crop we have to decide the irrigation pump? That is for the worst condition. Whichever the crop that takes worst water requirement or the large amount of water requirement, for us it is sugarcane. Sugarcane is the one which needs sufficient amount of water. We have to design the irrigation pump for sugarcane. So if you are going groundnut or any other crop which is taking less amount of water, then obviously that pump will be serving that purpose also. So similarly, crops will be requiring a different water requirement at different stages. There are mainly 4 different stages are there: initial stage, then development stage, then mid-season stage, and the late stage, where just before the harvesting. So out of all these different stages, in the mid-season stage, where crops are sufficiently grown and their leaves are sufficiently exposed to sunlight, during that time the water requirement will be sufficiently larger for the crops. So that is the condition we have to consider. We have to calculate the water requirement for that particular condition. Then we have to calculate the irrigation pump for the large amount of water requirement. Then it will suit for all the possible conditions. Once the head calculation is completed, then this is the equation which is used to calculate the pump rating. That is rho g q h, the h into q, which will give the pump rating in terms of watts. The pump rating will be available in terms of watts. Obviously, if you substitute all this data, then pump rating will be available. That is the, this may not be a standard pump rating, but we have to suggest the suitable pump rating. And all this explanation can be represented by this flow chart. And to validate this particular methodology, a case study, I'll be presenting a case study which was carried in Malaprabha riverbed. Malaprabha river is well known to all of us, North Karnataka people. In fact, it originates somewhere in Belagavi district itself. Bagalkot is also having good amount of help from this Malaprabha river. So this is the methodology employed for carrying out this energy conservation and analysis. First, we have to conduct a survey of agriculture land. We have to approach the farmers, ask them what type of crops they are going, what is their soil condition, and how they are carry out the irrigation for their crops. Then we have to observe their land, and we have to calculate the hydraulic head for that particular agriculture land. What is the distance from the riverbed? What is the distance from the bore well or the open well? Then we have to calculate the water flow rate. Then corresponding to that, we have to suggest them the optimum size of the irrigation pump capacity. Then once that is suggested, then we can, with reference to their existing irrigation pump, we can calculate how much amount of electricity we will be able to conserve. So this is the case study. Before that, I will be presenting the methodology that is employed. Okay. The whatever the methodology that I explained, so we have tested this using a MATLAB program. The MATLAB program is developed for the shade methodology, and this will be used to suggest irrigation pump for the farmers. When we run this particular MATLAB program, it will keep asking us the actual requirements of the farmers. Now it is asking the assessment of optimal irrigation pump capacity based on the crop water requirements and the local field conditions. So we have to enter the farmers details for this. In fact, we should have farmer in front of us, in front of the computer, then start entering the details. We are requested to provide all the crop details and the field details. Now it is asking to enter the different types of the crops. So farmer can enter the crop details. Now I will select some crops, maybe sunflower. Then it will ask how much amount of acres. Then I have to enter, I will enter it as 4 acres of sunflower. Now I have entered 4 acres of sunflowers. Then I can add some more. I can add maize. Maize is grown for around 5 acres. Then I will complete the crop types. Then I can finish the entry of crops here. Now I have completed the entry of crops. So 2 crops are entered and corresponding lands are also entered. This program says the total water required for agriculture land is this much amount of liters per day, that is 4,71,975, and the total hectares, 9 hectares is the land. Then it will ask the electricity supply hours, how much amount of electricity supply hours is there. Typically we use 6 hours. Then it will calculate for 6 hours how much amount of the flow rate is there. The total water required per day is displayed. Discharge rate in liters per hour is displayed. So it means corresponding to this we have to go further. Now discharge in liters per hour is around 78,000 liters. Then we have to select corresponding irrigation pipe network. Then it will ask how much amount of the distance is there. Enter the length in terms of meters. Now I will say around 300 meters of distance is to be traveled. Then it will calculate the total friction head. Then it will ask, is there any pipe network changes, diameter changes? I will say no change in the diameter. So it will display the total head in terms of the contraction and extraction, and finally it will display the total head offered due to the entrance and the exit and due to the pipe networks. Then we have to enter the number of bends in the pipe network. I have one number of pipe 90-degree bends, then one number of 45-degree bends. This can depend on the farmer's agriculture land. Then total head loss will be calculated due to these bends. Then we have to enter, is there any typical or different types of the walls used in the pipe network? So let us say no special type of walls. Then the head loss due to these minor things will be displayed. Then we have to enter what is the suction side head. So suction side, let us say we have 6 meters of distance, open well, or it may be a riverbed irrigation pump. So 6 meters, it means around 20 feet, 18 feet. So 6 meters is the suction side and the discharge side is around 4 meters. Then it will tell us suction side and discharge side heads, and the total head calculated is 13 meters. So 13 meters is the total head calculated. Total head in the sense the farmer's irrigation pump has to pump the water against this much amount of resistance. Then efficiency, typically the best efficiency point will be available to us. I use around 70% here, and this is quite less for DC water pumps. For AC pumps it is quite high. So with this, the power required to discharge 78,000 liters per hour at a head of around 13 meters is 4,235 watts. It means this can be converted into HP ratings. So now it is saying the required power rating is 5.6 HP. So as we are aware, we are all aware that 5.6 HP pumps are not available. Nearest pump size has to be suggested to the farmers. He might have installed 10 HP now, but his actual requirement is 5.6 HP. This is what we as engineers should suggest to the farmers. The farmers may not be directly agreeing to this because this will sufficiently reduce their water supply. But somehow we should convince them that this is sufficient for the healthy growth of the crops. Then we should always also convince them about the energy conservation. Then they might agree for this. Then the existing installed pump capacity, suppose for any case if it is 10 HP irrigation pump is installed, then the indication is excessive rating of the irrigation pump is around 3,214 watts. That much amount of excess installation is there. So we have to supply enter the operating hours of the irrigation pump, then it will calculate the energy consumed by the installed pump and the energy consumed by the newly proposed irrigation pump. Then the difference is stated. So per day we will be saving 41 units of energy with that. Then a total generation cost saved in per day is this much. Maybe per day 79 rupees can be saved if with 9 hours of operation. So if meters are available, then this can be very effectively done. Then we can actually calculate what exactly is the consumption from the farmer's end. Well, this demonstration, I hope, will make you to understand what exactly is the need. This methodology used for the case study that we have carried out. A case study was conducted at Malaprabha riverbed near my home village, that native place, Kitli village. A critical survey was conducted with around 51 farmers, and the details of all the irrigation pumps and pipe networks and the crops, all that is collected. Then we suggested them the irrigation pump capacities. So there is an image which shows the location of the survey that we carried out, and this shows the potential that is available for the Malaprabha river to provide water for the irrigation to the farmers. Sufficient amount of potential is there. Some of the images while carrying out the case studies, river beds of the Malaprabha river near Badami Taluk in Bagalkot district. So some of the images while carrying out the case studies, also discussions were carried with the farmers. You can see the sufficient amount of water availability in this, and while collecting data also we taken some images. The results of all these case studies, now we collected the data from the farmers, then we used in our methodology or the program. Then the results revealed this information. The diagram that I have shown in the screen it indicates there is a sufficient amount of energy conservation opportunity available in the irrigation sector. The word energy conservation opportunity, I hope everybody is quite familiar to this word. Energy conservation opportunity is the provision which is available to save electricity. So this diagram shows that sufficient amount of electricity can be conserved in irrigation. Now what this diagram indicates is there is 11 farmers and 21%. What this indicates is less than 20% of the farmers out of 51 cases, whatever that case study is done, less than 20% farmers have this much amount of excess electricity. It means excess, only 11 farmers have optimal pump capacity. So there are some 12 farmers, 23% of 51, which have 20 to 40% of excess electricity. Right? They have 20% excess electricity. 12 farmers have 40% excess electricity. There are some farmers which have 40 to 60% of higher excess capacity installation. So there are some 7 farmers which have 60 to 80%. It means all the farmers, most of the farmers have installed excess capacities. If the capacity is excess with 10% or 20%, well, it is not a big thing to rework on that. But when there is more than 80%, look at this, there are 2 farmers which have installed more than 80% than their requirement. Of course, I told you very clearly, it cannot be claimed as a mistake done by the farmers, because they know their issues. They will be struggling to supply the water. So obviously, in that angle, they install some larger capacity. But as engineers, we should always think about preventing these excess installations. Now, when we observe individual farmers critically, there are 51 farmers. I have drawn this graph or the bar chart by comparing. There are 2 lines in all the individual cases. One is blue colored line, which indicates the existing irrigation pump. Red colored is the optimum pump which we suggested the farmers. In many cases, most of the cases, in the first few cases, the pump capacity is 5 HP, whereas the suggested pump capacities are very less, maybe around 2 HP or 3 HP for their actual requirement. Now, these farmers will not be using all the time their irrigation pumps to their own lands. They'll be giving this to rent for nearby farmers, using the water which is available in the river. Some amount of everyday use. There are remaining cases where the installed pump capacities are much larger than their actual requirements. There are some interesting observations at the last. There are a few cases where whatever that we suggested the farmers, that was larger than their actual requirement. So it means that there are farmers which have some lesser requirement. Now, what these farmers will be using is, they will be requesting these farmers for their water requirement. Now, ultimately, this diagram only alone indicates there is sufficient amount of conservation facility available. So this indicates excess capacity installed in survey cases. So whatever the red colored line indicates, all these are excess capacities. Now these excess capacities are in the opposite direction. It means that much amount of shortage is there in the installations. So this is how the energy conservation is calculated. Energy conservation, cost savings, and CO2 reduction is calculated. Cost savings, suppose if you save around few number of units, then it can be multiplied with 2 rupees, maybe thinking that 2 rupees is spent for that much amount of electricity generation, then we can save that much amount of rupees. Then this is about CO2 emissions. In the standard protocol, we can get this from references. It is estimated that each unit of generation in India accounts for 0.9 kg of CO2. It means it is not the weight kg of CO2, it is volumetric. It means 1 kg of or 1 unit of electricity will prevent 1 kg of CO2. It means, so maybe like 100 party balloons of CO2 can be reduced. Maybe room size CO2 can be eliminated by just saving 1 unit of electricity. So it was observed from the results that out of the case studies, around 30% of excess installation was there. So even though we are calculating sufficient amount of water requirement in all the calculations, when we calculate the actual water requirement, we should also account for some losses. There will be some cracks in the land which will not be feeding to the agriculture crops. So we have to calculate, we have to take care of this cracks also. Then with sufficient amount of water is being supplied to the farmers, even then 30% of the excess capacity are installed. So in the total, in the case study, total capacity of 250 can be brought down effectively to 129 HP without affecting water supply quantity. So which indicates there is sufficient provision is there. Now this is the ongoing work. Some of our students are working on developing an Android application for calculation of the size of the agriculture pump. So nowadays farmers, most of them are using smartphones now. Even the traders or the shop owners can also use this particular app. This app will be suggesting us if the farmer is giving all his agriculture land information. I have shared the screenshots of the Android application, which is under development stage now. If the farmer is entering all his data in this particular Android application, at the end of this will provide them the actual requirement of the irrigation pump capacity to his requirements. So then he can make use of this, and very soon we'll make it available in the Play Store, hoping soon. And these are some of the laboratories which are established for SPV powered irrigation pumps. There are 3 DC irrigation pumps are there in our campus. Some of our students which are there in as a participant are experienced working on this. 3 irrigation pumps are there, 0.5 HP, 1 HP and 2 HP irrigation pumps. Corresponding to that 400, 900 and 1800 solar panels are connected to this. Whatever the methodology that I explained till now, that was validated by conducting the experiments in this particular laboratory setup. So because whatever that we do analytically, they should always meet the requirements of the farmers. It is not just the methodology is proposed by engineer. It shows that energy can be consumed. If it is not working in actual system, it is not of any use. So that proposed methodology is validated by conducting experiments, and we have developed this custom developed setup to monitor the performance of these irrigation pumps. So which is installed under different grants of the research grants under VGST and TechUp grants of our institution. These are some of the images while testing the irrigation pumps. Our head of the department, Dr. Jangam Shetty, is there in the pic, and these are some of the pics while conducting the internship for the undergraduate students. Internships will be conducted on this setup to study and to understand the methodology of irrigation pump. Students will be designing their own irrigation pump for the given requirements. So these are some of the references. It means we are our own technical publications published by us using this particular setup. Students can make use of this and for validation of the methodology. If any questions, then we'll spend some time on it. Hello.
Thank you, sir.
Yes.
Dear participants, do you have any questions to be asked?
Okay, I have some question or discussion made in this chat window. Looking for Karnataka State's electricity tariff. For farmers, as of now, Karnataka State government is providing electricity free of cost. So there are no metering facilities. However, the meters are located at the transformers nearby the agricultural lands. But if the meters are located for the individual agriculture pumps, well, the energy conservation or energy analytics can be critically monitored. It will also help the engineers to achieve energy conservation.
Hello. Hello.
Yes.
Hello. Hello.
Yes, sir. Yes, sir. Please go ahead, sir.
Sir, I want to know one thing. During the rainy season and during the dark weather, how solar cell power generation can be suitably adjusted?
Yes, sir. So during the rainy season and dark sunlight, like with reference to irrigation pump, uh, in fact, in most of the discussion when we speak about irrigation pumps and the solar system or SPV powered irrigation pumps, it is mentioned that it is most suitable because rain and sunlight are complementary in nature. Whenever it is raining, obviously there is no need of irrigation for the crops. So obviously, as far as irrigation pumps are concerned, when it is raining, SPU power, if it is not generated, well, even then it is okay with irrigation pumps. But as far as the independent SPV systems are concerned, during the rainy conditions, or the while it is drizzling, even then there will be some amount of electricity generated. Even if it is drizzling, whatever the setup that I have shown, a 2 HP water pump, which is coupled to 1800 watts, that will be pumping the water even if it is the it is drizzling, because it doesn't need all the time direct solar radiation. Diffuse solar radiation is quite sufficient to operate, but the water pumps will not be operated effectively. So, and one more thing is DC pumps can
Yeah.
be used for operation of the SPU power systems, because when you are using AC pumps demand some fixed amount of voltage to be operated, whereas DC pumps don't demand of that kind. If the
Yeah.
voltage is less, solar radiation is less, they will operate little lesser, that's all. So DC water pump starts operation at the morning 8 o'clock, they will keep operating up to evening 5:30 or 6, nowadays even 6 also, because even though solar radiation is lesser, they
Yeah.
will pump lesser amount of water. Whereas AC water pumps, if you want to employ inverter base, then they will be operating, maybe they will start operating at 10:30 or 11, that is maybe around 800 watt per meter square solar radiation. Maybe they might stop operation at around 3:30 or 4 o'clock, whereas in DC case, it will not be the same.
Okay. And then one more thing is we can operate the pumps with variable frequency drive so that it can save power.
Yeah. Yes, sir, obviously. That is just another advanced option for the energy conservation.
Okay. Thank you very much.
Thank you.
Sir, there is one question from the participants
Yes.
regarding the cost of entire plant, sir. So, what is the cost sir?
Hello, sir. Ronad, sir, are you there?
ಇಲ್ಲ ಆಫ್ ಅಲ್ಲ ಸರ್
Yeah. Hello, Santosh. Hello.
Yes, sir.
Yeah. Please ask. Please ask the question. It was some technical error in that. Please ask.
Yes, sir. Anybody has doubt, participants? So there's a question.
Okay.
Please, could you please start?
Sir, there is a question regarding the cost of the entire plant.
Okay. Okay. So, as far as the cost of the SPV systems and the corresponding irrigation systems are concerned, SPV panels will be costing, as nowadays it will be available with 40 to 50 rupees per watt. Maybe in 2012-13 we used to take it as 90 rupees per watt, including installation and transportation. However, the including subsidy, it will individually might have to. But as far as the cost of the irrigation pumps are concerned, the cost of DC pumps will be much higher than the conventional AC irrigation pumps what we use in the farms.
Okay, sir.
Hello?
So there's one more question.
Okay.
Is transpiration affected by irrigation method?
Okay. So irrigation method don't have anything to do with the transpiration. Basically, transpiration is so it means whatever the crop leaves are exposed to sunlight, if it is sufficiently large, well, then transpiration is sufficiently larger. If the crop leaves exposure is lesser, then obviously transpiration is less. So if the distance between the crops, whatever that is employed in the farms, that will affect the transpiration, not the type of the method of cultivation or not method of irrigation.
Hello.
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 Yes.
This is
Sir,
Riyaz
this is
Kazi.
Santosh from Anand.
I appreciating the presenter for taking this subject, very interesting subject, because there is no fake focus on the irrigation and the farmers due to the tariff issue. I appreciate. One suggestion from my side, as rightly told, that the DC pump are more effective for irrigation purpose. So if you have any data of water extracted from the well or the river, and compared to the irradiation.
Yes, hope you are asking about the performance of the irrigation pumps with reference to solar radiation. Am I right, sir?
Yes, yes.
Yeah, that performance data is readily available for three sizes of irrigation pumps: half HP, 1 HP, and 2 HP irrigation pumps. In fact, whatever the test system or the experimentation system that I shown in the presentation is developed for monitoring the performance of the irrigation pump. So every second or every few seconds, flow rate, the head available, and corresponding have that all. In fact, in one of the publication which we have presented, that is performance of SPU power irrigation international conference, you can get available in that.
Whom I need to connect with for a further offline discussion and support in other aspects of energy efficiency for your college or institute?
Sir, you can contact Dr. Suresh Jangam Shetty, who is Dean Research for our institution, who is also heading the Department of Electrical Engineering. In fact, who is also my research guide. You can always be in touch with him. So you can get the details of him through the organizer of this particular meeting, Mr. Professor Alok. He will be able to give you.
Request to type his details in the chat room. That will be great help.
Yes,
Thank
Alok,
you.
can you please do that?
So we have one more question.
Yes.
Hello. Hello. Good afternoon, sir.
Yes. Yes, please.
This is Kamlesh from Agri Engineering College, sir.
Yes.
Sir, can you suggest any tools and guides for effective and effective irrigation, sir? Effective
Tools and
and
guide
efficient
in.
irrigation.
Okay. You mean you're asking about the suggestions or the documents to read?
Sir, suggestions, sir.
Suggestion for effective irrigation. No, well,
Yes,
the
sir.
effective
One
irrigation
more question.
and okay.
Same for will it be
Pardon?
same for all the farmlands or will it be a different, sir?
Yes. The second question is quite important and interesting. I will answer.
Yes, sir.
First thing,
Hello.
in fact,
Ask.
the farmers are the most experts and experienced in this particular topic. But what
Yes.
we engineers are doing is we are helping the farmers, or
Yes.
on other hand, we are helping the system or the nation or the society.
Yes, sir.
Even in the present scenario, assistance of the engineers to carry out the irrigation or the agriculture. So they are experts in that. So presently there are many modern methods are available for drip irrigation. In fact, SPV is quite widely employed. In fact, SPV has been initiated in
Yes, sir.
however, is not been successful. The one of the reason for this is the cost of the SPV panels. Nowadays, cost of the SPV panels is reducing. It's quite reducing drastically. And also, we being North Karnataka people who has blessed with sufficient amount of solar radiation, this will be most suitable option. And the
Yes, sir.
second thing, what you asked about, will it be suitable for all possible?
Yes, sir.
The same methodology may not be directly suit. We have to make some required modification. So suppose for Belgium, if you are employing the same methodology, whatever the 1 HP irrigation, so it always depends. The word that is called as site specific or the based on the field condition. If you use the actual field condition, it is more nearer to your actual requirements. So always we should use the field conditions, then the results will be very much accurate. So that is for your second question. This will not be common for all the possible sites.
Okay. So can we use a hybrid system instead of using only solar panels, sir?
Obviously, if the wind potential is quite high, then you can always use the hybrid system also. But what happens?
Sir.
The
Yes, sir, proceed,
reliability,
sir.
there will be always improvement in the reliability, but only thing, the wind potential should be sufficiently high and it should be made available continuously.
But is there any problem of synchronization when we are using hybrid systems, sir? Because we are using
Can you
two
ask?
systems.
Okay.
Is there any problem of synchronization?
Okay.
So if you
Now,
want
when
to
you are
use,
using them,
sir.
okay. When you are using them in the DC mode, there should not be any issue with the synchronizing. When you are using AC pumps, then there will be an issue, obviously. But even then, when you are using them as in a from morning 10 o'clock, but the thing is, so all the time, whenever solar is available, so wind may not be available. So sometimes wind, we don't know, wind may be fluctuating very frequently, whereas solar is not like that. Solar is available at least for the fixed amount of time. Solar
Yes.
will be available. So we can trust directly the solar. Wind can be used, but not for the real time.
Okay. So if you want to use the wind, sir, wind turbines. So what is the minimum wind speed required to run that plant, sir? Hello, sir, can you hear me? Hello.
Yeah, look, I'm using with another ID, so kindly don't mute this one. I'm using with Dr. Basangouda, Ronad, something like this. So where is the admin? Kindly don't mute this one.
Yes, sir. Yes.
Okay, I'm using the other one. It is continuously getting muted by the admin. So please. Okay, I will come back to the answer. When you are using the hybrid system, no? So your question about a hybrid system, right? Operating the irrigation with hybrid system.
Yes, sir. Hybrid system. Yes, sir. Hello. ಏನು ಪ್ರಾಬ್ಲಮ್ ಆಗ್ತದೆ ಸರ್ HP ಡಿಸ್ಪ್ಲೇ ಕನೆಕ್ಟ್
I think there is a lot of disturbance.
Yeah, Alok.
Yes,
Alok.
sir.
Yeah, Alok. I'm using this. My name is displayed, no, because I logged in my mobile. So organizer is muting this one. So you can mute that HP one completely. So I will be speaking on this. Don't mute this one, the one in which I am speaking now, please.
Yes, sir.
Okay, sir. Okay, sir.
Okay. Please ask the question again, please.
Sir, if you hello, sir.
Yeah.
So if I want to set up a plant using a wind turbine, sir. So what is the minimum wind speed required to set up in our area? Whether it depends upon the longitude or the latitude or the height, any factors we need to be considered, or just we can set up the plant, sir. I just want sir. Yes, sir.
Now, if you want to establish the WTG system, wind turbine generator, then obviously you should have the wind data availability in that particular location. So
Yes,
wind data availability is sufficiently high, then we'll always, you can straight away go ahead. What will, it depends also on what is the load. So
sir.
depending on the load, you should always match the what is the power generated, what might be the power generated. Every wind generator will have power
Yes.
how much amount of
Sir, ಅವ್ರು ಯಾವ್ದೋ ಬೇರೆ ಯೂಸ್ ಮಾಡ್ತಿದ್ರು ಅದನ್ನ ಆಫ್ ಮಾಡ್ರಿ ಅಂತ ಹೇಳಿ.
hello sir. Hello. Yes sir.
Yes, sir. Yes, sir. Proceed, sir. Hello.
Yeah, about WT system. Now, if the wind data availability in that particular location is known, wind speed, so then
Yes, sir.
obviously based on the load requirement, whatever the wattage of the load is there, based on
Yes,
that
sir.
you can always calculate how much amount of WT system is required. Then corresponding to that, you can use WT system for generating the electricity for that respective load. So obviously you asked about the different parameters to be considered for suggesting the or selecting the wind turbine generator.
Yes, yes,
Well,
sir.
because it always depends on the load and the local wind speed availability.
Yes,
So
sir.
if it is connected to the grid, if you want to install a wind turbine generator and you want to generate electricity and you want to connect it to a grid, that is different part. So you can just straight away connect. You have to look into whether how much amount of electricity you can generate using that particular plant. When you
Yes,
are
sir.
using as per as a specific load, for example, if you are using the wind turbine generator for a irrigation pump, then
Yes.
obviously you should have to look into the wattage of the irrigation pump, then local wind speed availability, then you have to look into the wind turbine generator, how much amount of wind power can be generated in that. Also you have to you should look into reliability of that. If sufficient amount of wind is not available continuously, then you have
Yes,
to
sir.
supply that maybe using SPV panels or maybe using the batteries. Otherwise, you, as a standby, you should also have the grid connection also, because for this you should have strong data available, that you should be
Yes, sir.
very clear that at least for this part I will be made available with the wind. This information should be available.
Okay, okay, okay. And that means the grid system is totally different from standalone system, sir.
Quite obviously. So that is
Okay.
grid and it is standalone. That as the name itself
Standalone.
suggests.
They're totally different. The parameters
Yeah.
also will vary.
Parameters in the sense, if you want to operate, if you have a DC irrigation pump or any load, not only pump. So if
Ah,
you
sir.
want to operate that continuously, then you provide a standalone independent source for that. If it is
Yes.
fulfilling the requirement, well, operate it independently as a standalone system. Suppose whenever there is energy availability is not there, as it is a renewable, then in all
Yes.
such cases you can always make use of the grid as a supporting system. Otherwise, you can also rely on the batteries if the batteries are proving to be economic for your application.
Sir, one more last question, sir.
Yeah, please.
Does location matter, sir?
For WD system, you're asking?
For both, sir. For
Yeah, it
SPV
quite
and
obviously, because no, why this location matters is even though you are not working with renewable, if you are working with irrigation, then also location matters, because
yes,
the irrigation requirements always depends on the crops and the climatic conditions. Corresponding
yes,
to that, we will be suggesting or deciding the irrigation pump capacity. So when you are sticking into renewable energy sources, it's quite obvious all the locations will have different wind and solar potential. So
Yes, sir.
for that purpose, for I give an example, 1 HP DC irrigation pump which is operating in Bagalkot, it may not
Yes, sir.
operate in the same way in Belgaum because of the solar radiation in Belgaum will be some completely
It's
different
totally
as compared
different
to
in
Bagalkot.
Belgaum city. It's around 1,000 watt hour per meter square. Yes, sir.
Not all the time. Belgaum depends because in Bagalkot we get not so difference in Bagalkot and Belgaum as far as
Yes, sir.
peak value is concerned. But it will be cloudy. There will be more in Belgaum, it seems. So what we feel. But
Yes.
otherwise, always it depends on the location and the respective wind and solar potential.
Yes, sir. Yes, yes. Okay, sir. Thank you, sir. Thank you for your valuable answer, sir. Thank you. Thanks a lot.
Thank you.
Just an add one question, sir.
Yes, please.
Hello.
Yes, please, sir.
Sir, you see, usually the farmers' family from generations they have practiced one type of cultivation and agriculture. So with the sudden
Yes.
change to the modern system,
Okay.
how do you see the children of the older generation adopting themselves?
Sir, it's not about the question of adopting. Like the same system continues. The whatever the
Yes.
as of now, actually, whatever that I presented, one important point was drip irrigation. Presently, drip irrigation is very
Yeah.
common. Maybe 10-15 years back, it was quite new. But every individual farmer is aware of drip irrigation now. Even their children are also aware about this. So that adopting to,
Okay.
because it is not a high-price system, it is not a software-based system where farmers sons may require to operate some softwares or tools or something. So it is a straightforward device which farmers will be quite convenient. So that is why in many cases like advanced technologies or interventions may not be employed in that these kind of irrigation and other farmer related activities. So most of the cases, like for
Hmm.
example, if the AC irrigation, conventional AC irrigation pumps are there, so winding work, repair work, all the lines work, farmers will be quite advanced. They will be having
Yeah.
sufficient knowledge even than the electrical engineers. They will be operating on that. So by practice, they will be employing this. That it is not a high-fi technology that farmers will be facing difficulty in operating or something.
Okay. These systems are all farmers friendly.
Yes, sir, obviously they will be farmers friendly. Now, another thing advantage is if the solar PV systems are installed, suppose, then what happens is, suppose if it is a rainy
Hmm.
season or all the time irrigation will not be employed. There will be some hours which are called as off pumping hours, or the irrigation is not being done during that. So now there are schemes where
Okay.
farmers can generate electricity and they pump it to grid. So they will get some revenue also through this provision. Irrigation is also helping farmers now. So your irrigation pumps are coupled
Thank
to
you. Thank you.
panels. So yes, Alok.
Yes, sir.
Yeah, is there any other question?
Sir, no, sir. So thank you
Okay.
very much for wonderful presentation.
Yeah, thank you, Alok. I think yeah,
I would like
uh,
to invite
maybe
Rajasthan to give the vote of thanks, sir.
okay.
Thank you, sir. Good afternoon, all. I, Professor Alok Kulkarni, on behalf of Indian Institute of Technology and Management, Belgaum, I thank today's resource person, Dr. Basangouda F. Ronad, sir, for accepting our invitation in his busy schedule. So I extend my heartily thanks to Dr. Basangouda Ronad, sir, for sharing his valuable knowledge on energy conservation in irrigation system, which was very informative for the participants. Thank you, sir, for spending your valuable time with us, sir. Thank you, sir. And I also thank Sri Raju Joshi, sir, administrator of Suresh Angli Education Foundation, Belgavi. I also thank Dr. Anand Deshpande, sir, principal and director of AITM Belgavi, who supported us conduct today's webinar. I also thank our head of the department, Professor Vasant Kumar Upadhyaya sir, and all the staff members of electrical and electronics engineering who work tirelessly to make it successful. Last but not the least, I also thank all the participants who joined through GoToMeeting and made it a grand successful. Thank you all. Thank you, sir. Thank you once more for your valuable time, sir.
Thank you,
Thank you.
Basangouda, sir.
Thank you,
Thank
sir.
you.
Thank you, sir. Kindly be online. So, shall we make now it will be online the photo and we can take the photo.
Thank you, sir. And for participants, we already circulated the feedback form. So please fill the feedback form and get the certificates for today's webinar. Thank you.
ಸರ್ ವಿನ್ನರ್ ಬ್ಯಾನರ್ ಯಾರ ಹತ್ರ ಇದೆ
WhatsApp. So shall we end the meeting?
ಸರ್ ಏನ್ ಮಾಡ್ರಿ
No, sir. I think the sir is left. Where, sir?
ಹಿಂಗೆ ಮಾಡ್ರಿ
Sir, we'll end the meeting.
Sir, where is the feedback form? Kulkarni sir, where is the feedback form?
Yeah,
This conference will now be recorded.